Good morning. It's April 18th, and this is your daily brief in science. Here's everything you need to know. Scientists have detected dimethyl sulfide, or DMS, in the atmosphere of K2-18b, a planet located 120 light-years from Earth. This finding raises intriguing possibilities about the existence of life beyond our planet, although researchers are urging caution in interpreting these results. The discovery was made through independent observations using various instruments on the James Webb Space Telescope, or JWST, which demonstrated consistency in the data collected. Lead author Nikku Madhusudhan from Cambridge University emphasizes the importance of these findings, but highlights the necessity for further observations to validate the results. Despite the promising signals, some researchers have raised concerns regarding the reliability of the data, suggesting that the signals detected might be statistical noise rather than genuine biosignatures. Skepticism remains within the scientific community, with unresolved questions about the planet's classification and alternative explanations for the detected compounds. Nicholas Wogan from NASA pointed out the need for independent verification of these findings, a process that could take weeks or months due to the complexities involved in analyzing JWST data. Experts like Laura Creedberg stress that the detection of these gases requires further confirmation, advocating for extraordinary evidence to substantiate such claims. 3 critical questions must be addressed regarding the DMS signal. Its authenticity, whether it can be specifically attributed to DMS, and if it could arise from non-biological processes. The presence of these compounds has not been definitively confirmed, raising significant questions about the reliability of the findings and the need for rigorous verification. Future observations with the JWST and upcoming NASA missions will be essential to determine the planet's habitability, although budget constraints may pose challenges to these efforts. The ongoing search for extraterrestrial life continues to captivate humanity, exploring the complexities of alien atmospheres. This discovery also reignites interest in the Fermi paradox, prompting discussions about why intelligent life has not yet been encountered despite the vast number of potentially habitable planets. A recent study from the University of Cambridge has revealed promising findings regarding metformin, a common diabetes medication that costs just 35 pence per pill. Researchers suggest that this medication may help prevent acute myeloid leukemia, or AML, a particularly deadly form of blood cancer. Currently, there are no effective treatments to halt the progression of AML once it develops, making this discovery particularly significant. The study, published in the journal Nature on April 16, 2025, was supported by organizations such as Blood Cancer UK and Cancer Research UK. It focused on the DNMT3A gene mutation, which accounts for 10 to 15% of AML cases, and aimed to prevent abnormal blood stem cells from transitioning into cancerous cells. The findings indicated that blood stem cells with the DNMT3A mutation are heavily reliant on mitochondrial metabolism, making them susceptible to metformin, which targets this process. Experiments conducted on both mice and human samples demonstrated that metformin significantly slowed the growth of blood cells bearing the mutation. This suggests its potential effectiveness in preventing AML. The next steps for researchers include conducting clinical trials to evaluate metformin's effectiveness in individuals at high risk for AML, capitalizing on its established safety profile to expedite new preventive therapies. Data from over 412,000 participants in the UK Biobank indicated that those taking metformin were less likely to show changes in the DNMT3A gene, further supporting the drug's potential protective effect. Researchers found that metformin disrupts the disease process by impairing energy production in precancerous cells, preventing their progression into leukemia. Dr. Rubina Ahmed from Blood Cancer UK highlighted the urgent need for better treatments for AML, which has a low 5-year survival rate of approximately 20%. AML is particularly lethal, with around 4 out of 5 patients dying within 5 years of diagnosis, and approximately 3,100 new cases reported each year in the UK. This breakthrough in drug repurposing could pave the way for new cancer prevention strategies, potentially offering life-saving options for vulnerable populations. A recent study published in the journal Science reveals transformative insights into the synaptic mechanisms that facilitate learning. Conducted by neurobiologists at the University of California, San Diego, this groundbreaking research challenges the long-held belief that synaptic changes in the brain are uniform across neurons. The study found that synaptic plasticity, the process by which synapses strengthen or weaken, differs across various regions of a neuron. Rather than adhering to a single set of rules, individual neurons utilize multiple synaptic plasticity mechanisms simultaneously. Utilizing advanced two-photon imaging techniques, the researchers tracked synaptic activity in mice engaged in learning tasks, revealing that distinct regions of the same neuron adapt through different plasticity rules. This finding not only reshapes our understanding of how the brain encodes new information, but also addresses the credit assignment problem. It explains how localized synaptic changes contribute to broader behavioral learning. The implications of this research are significant, suggesting potential advancements in treatments for brain disorders such as PTSD, Alzheimer's disease, and autism. Lead author William Jake Wright emphasized the health implications of understanding these synaptic modifications, as many neurological diseases involve synaptic dysfunction. Furthermore, the research could inform the development of artificial intelligence systems, proposing new designs for neural networks that incorporate multiple plasticity rules within individual units. Senior author Takaaki Komiyama noted that this work fundamentally alters our understanding of how distinct computations occur in neurons. The researchers plan to further investigate how neurons apply multiple plasticity rules simultaneously and the advantages this provides for learning and adaptation. These insights could also advance treatments for conditions like addiction and neurodevelopmental disorders, underscoring the broad relevance of the study's findings. Researchers at Linköping University in Sweden have unveiled a transformative battery technology that resembles a paste, allowing for unprecedented flexibility in design. This innovative approach employs liquid electrodes made from conductive plastics and lignin, a sustainable byproduct of paper production. By overcoming the limitations of previous rigid battery designs, this new technology paves the way for batteries that can be molded into various shapes, potentially utilizing 3D printing techniques. The flexibility of this battery opens up exciting possibilities for next-generation devices, including wearable technology, foldable phones, and medical devices such as pacemakers. Notably, the battery demonstrates impressive durability, able to stretch up to double its length and endure over 500 charging cycles without any performance degradation. However, it currently operates at a voltage of only 0.9 volts, which is lower than standard AA batteries and typical smartphone batteries. To enhance the voltage in future iterations, researchers are investigating alternative chemical compounds like zinc and manganese. Co-author Ayman Ramanuddin emphasized that this soft and flexible battery technology removes traditional design constraints, allowing for seamless integration into a variety of electronic devices. The use of abundant and sustainable materials also contributes to a more environmentally friendly approach in battery production, as highlighted by lead author Mohsin Mohammadi. This breakthrough could significantly revolutionize the design and functionality of future battery-powered devices, offering unprecedented design flexibility. The study detailing this innovation, titled "Make It Flow from Solid to Liquid: Redox Active Electrofluids for Intrinsically Stretchable Batteries," was published in Science Advances on April 11, 2025. Previous attempts to use liquid electrodes, such as gallium, faced challenges due to environmental concerns and inefficiencies during charging cycles. A remarkable discovery has emerged from the Dominican Republic, where a 16-million-year-old fossil of a dirt ant named Basiceros enyana has been found encased in amber. This finding marks the first record of the Basiceros group in the Caribbean, challenging long-held beliefs that all Basiceros species were limited to Central and South America. Measuring just over 5 millimeters, Basiceros enana is notably smaller than its modern relatives, which can grow to nearly 9 millimeters, prompting scientists to reevaluate the evolution of ant sizes. Lead researcher Gianpiero Fiorentino described the significance of this fossil as akin to discovering a diamond, due to its exceptional preservation and the insights it provides into the ant's camouflage abilities. The fossil exhibits advanced camouflage features and traits necessary for a predatory lifestyle, indicating that these adaptations were already present millions of years ago. Basiceros ants are known for their unique ability to blend into their surroundings by coating themselves in soil, a skill that has persisted for at least 16 million years. Advanced imaging techniques, including micro-CT scanning and 3D reconstruction, were utilized to analyze the fossil, revealing characteristics similar to modern dirt ants, such as specialized mandibles for capturing prey. Despite their adaptations, Basiceros inana went extinct during the Miocene epoch due to ecological changes, likely facing competition and losing their ecological niches. Dr. Phil Barden emphasized the importance of understanding the environmental shifts that led to these extinctions to grasp broader patterns of extinction. Fiorentino highlighted that over a third of ant species have vanished from the Dominican Republic since the Ambers Formation, underscoring the need to study these extinction events to protect current biodiversity. The presence of this fossil suggests that ancient land bridges may have facilitated the migration of these ants from the mainland to the Caribbean, enhancing our understanding of extinction patterns. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. We'll be back Monday with everything you need to know.